Ellis Island. So you can see here that we have the different scales: performance, verbal, and performance. Object assembly, clearly that is a, yes, you said dog, I hope. Block design, picture arrangement, tell a story, and so forth. Picture completion, digit span, so forth. So the different categories that are involved in the WACE, or excuse me, the WISC. The WACE is the adult version, is as follows. And you can see that it includes all the different subtests there, verbally and performance-wise. And again, a psychologist or psychiatrist would need to actually administer said test. Again, the WACE is the Wechsler Adult Intelligence Scale, the most widely used intelligence test. It contains verbal, performance, and nonverbal subtests. Nothing about age or anything else with regard to chronological or mental age with this. Your answer again, WACE has 15 subtests, block design, different from the Stanford-Binet. Gives us separate scores for verbal comprehension, perceptual organization, working memory, and processing speed. The principles of test construction: how do these people actually make these types of tests to be able to see what we've achieved or what we might be able to achieve in the future with future performance with regard to aptitude? Of course, the term standardized. We've all heard of standardized tests before. Standardization basically is based upon the normal curve or the bell curve, which we are familiar with from Unit 1, excuse me, when we looked at research methodology. So when we look at standardization in the bell curve, let's first of all define standardization. A test is standardized. Standardized. Because it's been given to a group of people, a pre-tested group, and those scores have actually fallen on and be able to be placed on a normal curve. So we will always get a big hump in the middle, which is average, and we will have extremes on either side. The tests that are given by your teachers are not standardized. Okay? Tests given by your school, like the SAT, the FSA, or the ACT, those are standardized tests. So again, it's tested on the normal curve. Question number 3, why is it important that we have a normal curve? Why is the normal curve used for standardized testing? Because it describes the distribution of so many different things. We can use a normal curve for lots of different things. In this unit, of course, we're using it for intelligence. So let's take a look at how that works. By the way, do you remember these numbers down here at the bottom? I hope you do, because you're going to need to know them for this chapter as well as the chapter on research methodology and statistics. All right, so I'm taking a look at the normal curve. We have here 100 is the average for the IQ of the Wechsler as well as the IQ test for Binet. And then we have what are called standard deviations. I hope it's all coming back to you now. Standard deviations. And this is one standard deviation below the average, one above, and so forth. Now when we get over here to 130 and plus, we're in the upper 2 percentile. So again, we put percents on here, 34 and 34, 13.5 and 13.5, and 2 on each end. And we have a little bit left over there at the very end. That would be the third deviation above and below the standard, or above and below the mean. 68% of people score within 15 points above and below 100. And folks, you guys would all be right in here, and some of you even out in here. Now, in looking at testing over all these years of using the Wechsler Adult Intelligence Scale, we found that people have been getting smarter. When we actually compared the old IQ test scores of the Stanford-Binet with the new ones of the WACE, here's what we find. Interesting. The average intelligence test performance has actually gone up since we started using these scores in 1915 all the way up into the 1990s. So basically every generation, or at least every decade or so, we have to actually change the test. We have to re-standardize it, and we have to make it a little bit harder, so we always have the average to be, hopefully you said 100. So what is this process, or what is this effect known as? It's called the Flynn effect. Question 61.3, number 4. The Flynn effect shows that intelligence test performance has been improving since 1930, and we don't really know why. Things that have been put forward that possibly explain it include better nutrition, better education, more stimulating environment, less childhood diseases, and smaller families, or families that they basically have greater communication skills. In looking at tests, we have two different qualities that we have to look at. They are reliability and validity. Let's start first with reliability. Basically, reliability is the extent to which we always get consistent results. If we give this test to this group, and this group, will we generally get consistent scores? There are two ways for psychologists and psychometricians, is what they're known as, to actually use to identify whether or not these are actually reliable test scores. They are the test-retest reliability, which is where we take the test and then we take the test again and see if the scores are reliable. We do it in different groups and compare those. And then we just take half the test versus the other half of the test and compare those as well. In developing a test, question 61-4, number 1, okay, 61-4, number 1, we take a look at it is important that it yield consistent results. To measure reliability, researchers use the test-retest method or the split-half method. And then you can turn the page. For question number 2, how is validity different than reliability? Well, now we've got two things again about validity. Validity is either valid because of the test is measuring what it's supposed to measure, that's the content. And I know you guys know about this because you probably had a teacher or two that have told you, we're going to have this test, but then they give you the test and some things they said weren't on the test or subject matter that was on the test they didn't tell you about. That makes it somewhat of a content invalid test. Please feel free, leave my name out of it, to talk to some of your teachers and say, excuse me, Miss or Mr. fill in the blank. Your test should be considered content, your content was incorrect. You tested on the things that you said you weren't going to test us on or did not give us fair warning. Thereby, we need to actually say that this test is invalid. Good luck with that, by the way. Predictive validity is the other type of validity where we are able to actually predict does this test actually predict what it's supposed to predict. And of course, that's the big knock against the SAT and the ACT. Do these tests really predict how well you will succeed in college? We'll talk about that in a minute. Let's go back and get our definitions. Validity, the extent to which a test measures or predicts what it's supposed to. So again, what's the difference then between reliability and validity? Reliability is consistency. Validity is, does it measure what it's supposed to measure? Is it reliable and is it valid? Two different things. Now, there are two different parts to validity. Content validity is the extent to which a test actually samples the behavior that you're testing. If I tell you I'm going to give you a driving test, and then I go ahead and also on the driving test I have you do something else like a written test on road signs, then that's not a content valid test because I didn't tell you. I told you you were going to do a driving test, the behavior of driving the car. I didn't tell you you were going to be tested on basically all the different minutiae of different road signs. Unless, of course, that's part of the test that I told you in advance. Predictive validity is the success to which a test predicts what it's supposed to predict. Sometimes this is also called criterion-related validity. In other words, we look at the correlation between test scores and whatever it is we're actually measuring. An example of that would be the SAT. The SAT is given with the idea that if you score well on that, you should have enough knowledge to be able to do well in school. Would you guys like to know what the correlation of the SAT is? It actually is just barely at 50%. That's how valid it is, yet it's part of the backbone of the entire college system. What's a better indicator of how well you will do in college? That actually is not a test at all. It's something very easy to calculate and already is calculated. You probably already know. It is you're right, it's your GPA, which actually has a correlation of over 53%, a better accurate record. Why don't colleges and other schools actually just take your GPA? I don't know. That's a good question. I've actually asked that question to college professors that I've worked with in grading the AP exam, and I still really never got a really significant, reliable answer. Okay. Basically, the idea is I think basically that colleges tend to not trust the inflation of high school teachers with regard to grades. So, the question 61-4, number 4, how does content validity differ from the predictive validity of a test? Well, you need to know the difference between your validity, folks, so here we go. Content validity is the extent to which a test samples the behavior of interest. If I'm going to test your driving behavior, then I need to make sure that test actually samples that behavior. Predictive validity is the success in which it predicts the behavior it's designed to predict. If you're taking a test and it's supposed to predict if you're going to be successful in college or not, then we actually go back and see who drops out and how the SAT scores work with regard to who graduates or who gets through college and how well they do. I would like for you to come up with an example of a test that actually does both content validity and predictive validity. You can think of it yourself or you can look it up in your book. Ladies and gentlemen, we have reached the end of Module 61, but at the end of Module 61 there are several different review questions that I think are good, a good measure to see if you've grasped the concepts from Module 61. They are as follows. Question number 1, when and why were intelligence tests created? I think it's important to mention that it was in the mid to late 1800s, and Binet's work actually began in 1904 with children that were in need of special help. Now, the rest of the answers, of course, are fill in the blanks. Please go ahead for question number 8, if you'll go down to number 8. I've already drawn the curve for you. You will need to fill in and perhaps shade the different standard deviations. And don't forget to label the percents at the bottom of the normal curve. And then don't forget there are 4 more multiple choice questions on the back. It has been a pleasure talking with you about the Module 60 and 61, about the origins of intelligence and assessing intelligence. Please go to our second video in the series on YouTube, which has to do with Module 62, 63, and 64. Thank you very much again, and goodbye, good night, until next time.